Hey, geometry. So moving into our last couple of quadrilaterals, we'll focus on for this unit trapezoids and kites, saving kind of the weirder ones for last. So starting with trapezoids, a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. And the non-parallel sides are called legs. So you see down here we got base, base, those sides are parallel, and then the non-parallel sides are called legs. The base angles are formed by the base and one of the legs. So down here we got base angles, and so we'll see those referred to over here. We actually have two sets of base angles. So in trapezoid ABCD over here, angles A and B are one pair of base angles, right? Not necessarily congruent like they're marked down here, but these are considered base angles. They're a pair of base angles. And D and C are C and D. Angle C and angle D are the other pair. So we got two pairs of base angles. If the legs of a trapezoid are congruent, if those two lengths are the same, then we call it an isosceles trapezoid. So if you have an isosceles trapezoid, so if a trapezoid is isosceles, then each pair of base angles is congruent. So you have J is congruent to F, G is congruent to H. So I guess I can jot that down. Angle J is congruent to angle F, and angle G is congruent to angle H. All right, and so we know that. If a trapezoid has one pair of congruent base angles, so all we need to see is just one pair of congruent base angles, then it is an isosceles trapezoid. These other two are going to have to be the same as well. And we could prove that, like we know, for instance, that parallel lines, same side interior, that those are supplementary. And if those are supplementary, these are supplementary to congruent angles, then these two angles have to be the same. So that's an isosceles trapezoid. All right, and so if a trapezoid is isosceles, if and only if its diagonals are congruent. All right, so the diagonals, and so in this case, RT is congruent to QS. All right, that is that's going to be true in a isosceles triangle. So if the diagonals are congruent, we know it's isosceles. If it's isosceles, we know the diagonals are congruent. That if and only if goes both ways. And of course, that's assuming we're dealing with a trapezoid that have those, one pair of parallel sides. All right, so some examples. The speaker shown is an isosceles trapezoid. So we know that these non-parallel sides, and I'm going to assume that these are the parallel sides since they look parallel. So we've got those sides are congruent. If the measure of angle FJH is 85, so FJH, this angle here is 85 degrees. Find FK, so we have FK, and K is in the middle. It's hiding in the middle here. Verify that, yeah. FK is in the middle there. So if that distance, I'm going to put an arrow there so we can actually see it. That distance there is 8. And then if JG is 19, so JG, this distance, I'm going to label that out there, that distance there is 19. Find each measure. So we have find FGH. So I know this is 85. Ultimately, FGH, I want that opposite one over there. This is 85. All right, so I can mark that. That angle there is 85 degrees. There's a few ways we could go about this. I know that these two are going to have to be congruent as well. So I know that these two angles, we could call them X if we wanted to. X plus 85 plus 85 equals 360. We know that much. We also know that I'm assuming these again are my parallel sides. So same side interior. These two have to be supplementary. So I'll do that. That's a little bit easier. So I'll say the measure of angle FGH plus 85 is equal to 180. I mean, they have to be supplementary. So the measure of angle FGH is 95 degrees, right? So that those are supplementary. All right, and then the next thing that we're asked for is KH, which is from the middle here, and so this is what we want to know, KH. Well, I knew that this distance is 19, so FH equals 19, so I'll say this, FH, and so that's because we're dealing with an isosceles trapezoid. We know the diagonals are congruent. So FH is I'm going to say FH, the distance, FH is equal to JG, which is 19. So we've got that much information, and then I never wrote down J. What am I trying to figure out here? Yeah, sorry, there we go. I've got this written down. All right. So FH is equal to that. So FH, this distance is 19 as well. And then if that's 8, so we know from the segment addition postulate, I could say, 8 plus KH is equal to 19. And so I could figure out what KH has to be. So if we subtract 8, we get that KH is 11. And so that has to be the length of that part. All right, so on to the next page. Quadrilateral here for us, A, B, C, D. Show that it is a trapezoid and determine whether it is an isosceles trapezoid. So let me get some points on here. All right, so got my points on there. Didn't draw my line super straight, so we'll see how this turns out. But it'll be fine. We'll work it out with points. So first of all, are we dealing with a trapezoid? So what we want to see is that we've got one pair of parallel sides. And so, is BC parallel to AD? Seems like they are, but let's check. So the slope of BC is going to be a rise of -2 and a run of 1. So that's a -2 slope. And then let's check AD. So AD, and so that slope is down 4/2, -4/2. That's also a -2. And so because they're the same, then those two are parallel. All right, seems good. Seems like a good start. But we got to make sure that the other two sides aren't parallel. So a trapezoid, we are defining it so that it is, exactly one pair are parallel. So we don't want it to be a parallelogram. And so are these other sides? What's the slope of AB? So slope of AB. All right, so rise is 1, run is 1, 2, 3, 4, 5. So 1/5 seems good. Slope of DC. So rise looks like 3, run is 4, 3/4. We are good. So that is not parallel. Not parallel, so we have a trapezoid. Trapezoid. And then we are supposed to determine whether or not it is isosceles. So these are my parallel sides. I'm going to mark it here, parallel. Those are my bases. And so are these two distances the same? I'm going to go ahead and do the distance from A to B. And calculate that with distance formula, basically Pythagorean theorem. Square root of horizontal distance is 1, 2, 3, 4, 5. So 5 squared plus vertical distance 1 squared. So we end up with a square root of 26. Right, 25 plus 1 is 26. Square root of 26 for that distance. Let's check our other side. DC. Horizontally, we're going 1, 2, 3, 4. Vertically up 3, 4 squared plus 3 squared. That's a familiar number, 3, 4, 5, right? So 3, 4, 5 triangle. 3 squared is 9, plus 16 is square root of 25. All right, so not quite, right? Remember, that's 5, of course. So those are not congruent. So it is not an isosceles trapezoid. All right, and then we'll pick up from there in the next part.